Hey there, so just take a look around you for a second. Everything you see is just bursting with color, right? But have you ever really stopped to think about how we see it? How your eyes and your brain cook up that entire experience? Well, the answer is probably not what you think. The science of color is actually this one big, beautiful puzzle, and we're going to start by trying to solve the very first piece.
Okay, let's just dive right in with a little thought experiment. Picture a bright red apple. Under normal light, yeah, it's red, no question. But what if you shine a pure blue light on it and only a blue light? Suddenly, that apple looks black. How is that possible? Why does that happen? The answer to this one little question cracks open the entire secret of how we perceive color.
And here it is. This is the big aha moment. We tend to think a red apple is red. But the truth is, the apple isn't creating red light at all. It's doing the complete opposite. It's rejecting the red light. And it's absorbing all the other colors. So the color you see isn't what an object is, it's the light that it throws away. It's all about subtraction. Let's see how that really works.
Probably the easiest way to wrap your head around this whole idea of subtraction is by looking at color filters. You know, like the kind you'd get in those old school 3D glasses or even just colored cellophane. They literally filter out light. So to really get filters, we just need two key ideas. First is transmit. That just means a color of light is allowed to pass straight on through. The second is absorb, and that means a color gets blocked, it gets soaked up by the filter. It's really just a simple gate. Some colors get a free pass and others get stopped at the door.
Now, for any of this to make sense, we've got to remember what plain old white light, like sunlight, is actually made of. It's not really white at all. It's a mashup of all the colors of the rainbow. But to keep things simple, we can think of it as a mix of the three primary colors of light: red, green, and blue. A filter's job is basically to pick and choose from that trio.
Okay, so let's put it all together. Imagine white light, our mix of red, green, and blue, sailing towards a red filter. The filter does its one job. It grabs onto the green and blue light and absorbs them. It only lets the red light pass through. So the only color that actually makes it to your eye is red. Simple as that. So this basic rule of absorbing and transmitting, it applies to all filters. But we can kind of break them down into two main categories. You've got your primary filters and your secondary filters. The rule for primary filters is incredibly straightforward. A red filter lets red through and blocks everything else. A green filter lets green through, and you guessed it, a blue filter lets blue through. Each one is like a very exclusive bouncer for its own specific color. But then we have the secondary filters, cyan, magenta, and yellow. These guys are a little more generous. Instead of letting only one primary color through, they let two of them pass. Let's just take cyan as an example. Cyan light is actually a mix of blue and green light. So a cyan filter does exactly that. It lets the blue and green parts of white light come on through, but it blocks or absorbs the red. And the result you see on the other side is that beautiful cyan color. Okay, so that's how filters work. Cool. But what about, solid objects, like your shirt or the walls or that apple we started with? Well, the good news is the principle is exactly the same. It's still all about subtraction. The only thing that changes is how the light actually gets to your eye. Here is the one and only difference you need to remember. Filters are see-through, right? So they transmit light through them. But most objects are opaque, so they reflect light instead. They bounce it off their surface and into your eyes. But that key action, absorption, is totally identical. What this really means is that the color of any object is decided purely by the light its surface reflects. All the other colors in the light source get absorbed. They get soaked up by the surface. The color you end up seeing is just what's left over. It's the light that managed to bounce off and make it to your eye. The two extremes here make this crystal clear. Think about a white sheet of paper. It looks white because its surface reflects pretty much all the red, green, and blue light that hits it. A black surface does the complete opposite. It absorbs all the red, green, and blue light, reflecting almost nothing back. That's why it looks black. And that brings us right back to everyday objects. A blue book isn't magically creating blue light. No, when white light from a lamp hits it, the surface of the book is simply absorbing the red and the green parts of that light, and it's reflecting the blue part right into your eyes. It's a professional color rejector. All right, you have all the tools now. You get transmission, you get reflection, and you get absorption.
You know how both filters and objects subtract light. So, I think it's time to put that knowledge to the test with a real brain teaser. You ready for this?
Okay, let's really think about this one. We have a secondary color of light, that's magenta, shining on a surface that reflects another secondary color, yellow. This is where it gets really fun. What color is your eye actually going to perceive? And the answer is red. If you got that, seriously, congratulations. If you didn't, don't worry at all because breaking this down is the ultimate test of every single thing we have just learned.
Okay, let's trace the path of the light step by step. First, our light source isn't white light, it's magenta light, and we know that's a mix of red and blue light, so that's all that's hitting the surface. Step 2, the yellow surface. It has a rule. It loves to reflect red and green light, but it absorbs blue light. So, when our magenta light, our red and blue mix, hits that surface, the surface goes, nope, to the blue light and absorbs it, but it happily reflects the red light. So the only color left over to bounce into your eye is pure red.
So there it is. Color isn't about what something is, it's about what it throws away. And with that little piece of knowledge, you can solve all kinds of puzzles about light. Which kind of leads me to one final thought for you. If you now understand how simple filters work by subtracting certain colors, how do you think a pair of red and green glasses can trick your brain into seeing an entire third dimension in a 3D movie? Something to think about. Thanks for watching.